Okay, so I guess we'll launch into our last presentation today, dealing with the topic of pesticides in the Great Barrier Reef catchment and marine environment. And personally, I think pesticides are probably one of the easier topics to engage with farmers and primary industries on, simply because you don't find them naturally out in the environment like sediments and nutrients. And while there certainly can be some debate about where a pesticide may have come from when we detect it in the environment, I think most farmers are quite aware and recognise their usage of pesticides in a range of the intensive cropping systems of the Great Barrier Reef catchment area. And for this particular presentation, I certainly have to acknowledge the great work done by the Great Barrier Reef Catchment Loads Monitoring Program. They've supplied a lot of the, particularly the water quality data that I'll be presenting and talking to you about in a bit more detail today. So hat tip to the fantastic work done by that particular team. Pesticides also, I think, have quite an interesting and quite dynamic history in Great Barrier Reef agriculture. In many ways, we've probably pushed some industries towards greater reliance on herbicides through advocacy for things like new farming systems, and they're quite legitimate shifts in some ways away from tillage and cultivation from a soil conservation perspective, but it's still pushed certain industries to rely much more heavily on herbicides. And we've also had quite a traditional long-term focus on what have been termed the priority photosystem 2 inhibiting herbicides, the things like diuron, atrazine, hexazinone. But as anyone that works in virtually any agricultural industry knows, those priority herbicides just tend to be quite a small part of what can be a very diverse pesticide suite involved in some particular crops. And I guess there's always been bubbling along in the background these questions about the environmental properties of a lot of the other or alternative herbicides in these industries in relation to the priority chemicals and what are their effects on the environment. Now, it's probably an important point to make about Great Barrier Reef catchment pesticide monitoring is that it's really ramped up of late, particularly in the last probably 3 to 5 years. So they're monitoring at a much greater number of sites now, so 30 out of the 35 basins that make up the entire catchment area. A number of the sites are starting to get really long-term data records, but probably even more importantly is that the laboratory screening of the water quality samples that are collected has got much more broader. And this figure could even be out of date, but now they're currently looking at least 86 different, what we would probably call broadly pesticide compounds in every water sample that they collect up and down the Great Barrier Reef catchment area. So it's really becoming an increasingly scrutinised and heavily monitored and comprehensively monitored environment. In many ways, we know more about pesticides and our understanding of how they're lost from the system and their transmission through ecosystems than probably nutrients and sediments. There's been a heap of great work done in the last 10 years on things like better understanding of their behaviour out in tropical and subtropical environments, so their half-lives out in the field. Lots of great work on rainfall simulation, looking at relative comparisons of different loss rates and different management applications for pesticide use by a whole range of different agencies. But perhaps more importantly is a lot of the recent research investment by government in the development of a much broader and comprehensive and robust suite of water quality guidelines for ecosystem protection for the Great Barrier Reef environment. And it wasn't that long ago that we probably didn't even have particularly good water quality guidelines for even some of the priority photosystem 2 inhibiting herbicides that we were most concerned about from an environmental perspective. But now, because of that government investment in things like development of species sensitivity distributions that you can see on the slide here, we've now got a much greater capacity to sort of understand and predict the impact of a whole range of, bigger range of herbicides and also the impacts of their mixtures on the environment. So if you look at this particular slide, the red boxes here capture the traditional priority photosystem 2 inhibiting herbicides that we used to solely concentrate on from a Great Barrier Reef pesticide water quality perspective. And you can see now that we've got a much broader range of 22 reference, or if you want to call them priority pesticides, that are used across quite a much a much broader range of GBR agricultural, but also other industries. There's also been some quite profound changes in the way that we monitor or measure progress in terms of water quality improvements with pesticides just in the last couple of years. And historically, we used to look at load reduction targets for pesticides in a lot of the earlier iterations of Reef Plan. And in some ways, it was quite a good story from a pesticide perspective. You can probably see these load reduction target graphs. And pesticides, in many ways, while the improvement may not have been as high as what some people would have liked, we're probably making better progress with reaching the desired 60% load reduction targets for PS2 herbicides at river mouths compared to the targets for sediments and nutrients. Now things have shifted towards progress tracking based on what's called the MS-PAF metric. And that was driven in large part by some quite justifiable needs to recognise the impacts of a whole much broader range of chemicals on the environment and also the interactions between all of them. So a lot of our targets now will be based around protecting at least 99% of the aquatic species at the end of catchments. And I probably don't have a lot of time to spend on this, but you can see sort of how the results might look into the future on this map here, showing the levels of species protection for a particular year down the GBR catchment. So green being good and red being an area where we've got to improve. And it's probably worth looking at in a little bit of more specific detail at some of the challenges that we're trying to grapple with better management of pesticides in a couple of the pesticide hotspots in the Great Barrier Reef catchment. And I'll start here with a little bit of the long-term water quality data for diuron, which is one of the key photosystem 2 herbicides that's used particularly in sugarcane. And I'll just start with an example here of the diuron data collected at Barrier Creek in the Burdekin catchment from 2011 to 2018. So on this graph here along the horizontal or x-axis, in that blue line there, that represents river discharge in Barrier Creek through time. And all of the concentration data for diuron collected through that period is depicted in the purple dots there. This red line here represents the current proposed diuron ecosystem protection guideline. And it's probably also important to note here that the scale of the concentration for diuron there on the vertical axis is represented on a log scale. So each one of the increments increases by an order of magnitude. And you can see from the data here in Barrier Creek that diuron exceeds that ecosystem protection guideline by quite a significant amount for long periods of time, just about each and every year. And again, to shift focus away from the Burdekin and Barrier Creek down to Sandy Creek, which is another near Mackay, another one of the real hotspots for pesticide management and loss. Here's a very similar data set there for diuron, with a number of different guidelines presented there. So the bottom red dotted line is the Water Quality Ecosystem Protection Guideline. The middle red dotted line, Irrigation Water Quality Protection Guideline. And at top there is the Drinking Water Guideline. But you can see there that the concentrations of diuron in Sandy Creek are consistently above that ecosystem protection guideline at the bottom, and for large parts of the year even exceed the irrigation water quality protection guideline. Another one of the big players that we tend to find that's really recently emerged in the water quality pesticide space is imidacloprid. It's an insecticide, so a bit different to the photosystem 2 inhibiting herbicides. And it's widely used across a range of different crops and other industrial and commercial uses in Australia. But it's used quite a bit in sugarcane and bananas. So this particular graph here shows us all of the imidacloprid water quality concentration data that's been collected as part of the catchment loads monitoring program over almost the last 10 years across the entire GBR catchment. And you can see since 2009, there's been quite a consistent and pronounced increase in imidacloprid concentrations through that time period. And that red line at the bottom of the graph, it represents the proposed aquatic ecosystem water quality protection guideline. And you can see there that there's been a similar increasing trend in exceedances of that guideline for ecosystem protection. So it's really emerged as a bit of a water quality concern. Probably due to a range of different things, such as changes in product cost with generics coming on the market, increased application rates, and maybe some issues surrounding exactly how the products are applied and placed into the paddock. But while that's a bit of a challenge, there's also maybe a good news story surrounding imidacloprid and the role for extension, which is, I think, important to highlight for all of the young aspiring extension staff, particularly in this particular audience. And that good news story is kind of outlined by an example I'm going to show here from the Tully River region, but it's also seen in a number of other regions. But from about 2012 to 2017, you saw a very similar increase in water quality concentrations of imidacloprid at the Tully monitoring site through time that we saw reflected at a GBR wide scale in the earlier slide. But then I think there was some really targeted, intensive, well-done extension in 2016 and 17. And we saw a subsequent decline in water quality concentrations of imidacloprid following that work that's continued to this day. So I think it's a really good example of the value of collaborations between farmers, extension staff, and water quality scientists. If it's done well, you really can get some wins on the board. So in terms of a quick summary of the impacts of pesticides, pesticides are widely detected right across GBR aquatic environments, from freshwaters right out into the marine environments. But the concentrations well out into the marine environments in the mid and outer shelf reef tend to be very low. We think that pesticides currently pose the greatest environmental risk to the ecosystems closest to the source of the pesticides, so where they're applied to paddocks. So we think freshwater wetlands, rivers and estuaries get exposed to the highest concentrations, and we know this, and that tends to be followed by the coastal ecosystems like the shallow seagrass and nearshore coral reefs. And the risks probably at the mid and outer shelf tend to be quite low.